Okay, so we can see the difference as you go all the way down to the point, and of course, this would be the subfascia down here. We're just going to make like a the side of a 2x4 or 2x6 or 2x8. Okay, that right there, and then we'll put an X in it because you know that's the side of the 2x4. So right to the outside of the 2x4, that's where all the 7 and the 12 meet right there. So that means the further away you get away from it, the wider the disparity is. This is very, very, very important in understanding plate heights and stance differential and everything else like that. So we're going to go to something else here, and we're going to get back to our chart here. Now, let's see here. We're going to get back to our chart, and we're going to finish this off. This is a lot of material for me to cover. I've never explained it and all this and been methodical about it. And so being a videographer and, you know, documenting all this is a pretty reasonable undertaking. Not Herculean, but it's good. And I'm glad that you can see the numbers on my calculator very well. I watched the other videos, and they came out pretty well. So you can see my calculator, the visibility of my calculator is really well. So now what we're going to do, we have 13.53. Now 13.56 here. That's the stance. From here, this plate height, all the way up. Not this plate height, but this is the top of the stance of the rafter, all the way up to here. And just to illustrate that again, just in case you forgot, the stance would be, I got a picture of it here somewhere. Just bear with me for a moment. Bear with me for a moment. Okay, here we go. This is the stance here, the stance of the rafter, okay? So this line right here is represented by this line, the top of this line. And if we would draw that line on the other paper, it would be here. You see what I'm saying? So it's from the long point to the long point of a long 8 to a short 8. Plumb cut. A plumb cut 8 and a seat cut, a level cut 8. Or some people call it a plumb cut and a level cut of an 8. Some people say long 8 and some people say short 8. It's all kind of terminology. So now let's figure this out. We got the length of our common for our 712 side. That's the 712 side, 712. All right. And we multiplied our hypotenuse by 1.937 feet. And that gave us 26.94 inches. All right. Then we took this and divided it by 12, 26.904, to get what it is in feet. And so we got 2.24 feet. Okay. There you go. Now we took this measurement also, 1.937, and we multiplied that by 7. And that gave us 1356. Okay. It was actually, in the calculator, it was 13.559. But we just took the 9 and rounded the next number up to 6. So that's how we got our 13.56. All right. This is great. This is going really, really good. Now, the next thing we want to figure out is the run for the 12-12 side. And this line represents the build up. Okay, the build up on the stance for the 12-12 side. It also, in theory, it represents the build up for the wall plate for the wall plate. Okay, it represents that too. Okay, now let's figure that out. Now we know that this side is 12-12. So what we want to do is divide 13.56 divided by 12 equals. Oh, you know what? There's something I forgot to do. because I did do all this stuff all over. I had actually got further than this, but I forgot that I didn't. So no, scratch everything I just said because it's wrong. Okay, now I'm going to show you something. Okay, I think this is on the other video, but I'm not sure, so I'm just going to review it because I don't know. Anytime you have interruptions, you're liable to not remember what you presented prior. So just hold on a second. And we're going to jump right back into this. It's a little windy out here, not real windy. So some papers are getting blown around and tossed and turvied and all that kind of stuff. So I need to bring my chair up closer to my seat. Okay. All right. Now, what we want to do, I'm going to show you this over again so you can get my illustration down pat. Now, this right here, this is a 12-inch overhang. That's to the front of the brick. This right here, this 3.5 inches here, it represents the width of the brick. And there's a 1-inch air space, okay, behind all brick. You know, it don't butt right up to the house. There's a 1-inch air space, and they keep the bricks attached to the house with brick ties. Okay, I didn't need to tell you all that, but I just wanted to throw that out. So now, before, they always put the brick up after you do your framing, okay, not before you put your framing up, okay. They typically do it after. Okay. They do it after. Now, so from the subfascia, the outside of the subfascia to the framing, this is before they put this brick up, is 16.5 inches. Okay. Or 16.5 inches. All right. Or in feet is 1 point. Well, let me see. I want to show you how to do this. 16.5 divided by 12 equals. Okay, 1.375. 375 feet. 1.375 feet. 1.375, and that's feet. 1.375 is the same as 16.5 inches. It's the same thing. It's just in feet. One is in feet, one is in inches. Let me put inch marks here, inch marks there. Now, the next thing that we want to look at is, since we know that when you come to your subfascia, if all your subfascia is lining up, sometimes it's rare, but sometimes on houses, they don't want the subfascia lining up all around the house. Some of them is lower or whatever. But in this case, we're going to be as simplistic as possible so you can get the principles. And so you're going to have this where the subfascia is lining up all around the house, around the corner of the house. It's going to be at the same level. So what we need to do is we need to look at this chart here, because when you come in 1 foot, if you only got a 1 foot overhang, the disparity between the 12-inch pitch and the this is the 8-inch pitch. I don't want an 8-inch pitch. I want one that's dealing with what we're dealing with. Okay, hold on a second, because I got one here with a 7-inch. Okay, here it is. Okay, this is the same thing. So here we got a 7-inch and a 12-inch pitch. Now, is something wrong here? This is not right. Okay? The disparity between a 7/12 pitch and a 12/12 pitch in 12 inches is not going to be 4 inches. So what we're going to do is figure that out. The way you figure that out is just by subtracting 7 from 12. And that equals 5. So this is 5. This should be 5 inches. This should be 5 inches, not 4. 5 inches, not 4. And then, I'm going to show you this again. So we know we got a 12-12 pitch. So what we do is go 12 divided by 12. And of course, that's 1. Okay. Because for every inch it's going out, it's going up an inch. So if it's going 16 inches, and that's what our overhang is going to be on this right here. It's going to be 16 inches, not 16 and a half. Okay. We're just going to do 16 and a half and make it easy and all that. So if it's going out 12 inches and it's going up 12 inches, so you already know if it's a 12-12, it's going up 12. But if it's going up, if it's a 12-12 pitch or slope and it goes out 16 inches, where it's going to go up 16 inches. All right. So that one's easy to figure out without a calculator. The 7-12, not so much. So 7, to figure this one out, you do 7 divided by 12. Because you want to see what this is going to be when you project this out. Not to 12 inches, but to 16 inches. In 12 inches, it goes up 7 inches. But if it goes out 16 inches, how many more inches is going to go up? Because you can see it goes higher from the base. It goes up higher. So we got 7 divided by 12 equals. We take the 7 and divide it by the 12. 7 and divided by 12 equals. And in my calculator, you can see is 0.083. Okay. Then we multiply that times 16. Because 16 is how much you want to see how much is going to go up. And you push that in. Okay, I did something wrong. 7 divided by 12 equals, yeah, it's 0.583 times 16 equals, okay, yeah, 9.333 inches. So from here to the base, all the way up to that point is 9.333 inches. 16 minus 9.333 gives us 6.666. Okay. Now that's important because that's going to tell you the differential between the two different plate heights. The two different plate heights that you're going to have to build up. So we're going to plug this in. 6. I need a better writing pen. This is skipping. 6.666. All right. 6.666 is the differential between this line and this line. Okay. Now, since 6.666 is a differential, that means you're going to have to subtract this 6.666 from 13.56. So let's do that. 13